Yeah. Hello everyone. Good evening. I know it's been some time since we have hosted a virtual event for you. So here we are back with our Tech Thrusters Talk series, and today it's gonna be an amazing series because we have brought up one and only Manav Sutar, the CEO here for CEO of Single Core Labs, and they are going to give you an overview on why the AI agents actually fail in production code bases, production systems, as they look better in demos and a lot of different dev systems and demonstrations, but that's not actually the case. Why the AI agents can break and have some side effects into the real systems? That's all gonna. That's all we gonna learn in this today's session. So rather than I would say rather than wasting your time and give you a great informative session ahead, I will ask Manav to come on the stage and give it a go. Also, please share a round of applause in the comment section. If you have any doubts, feel free to drop them in, and Manav can answer them. Yeah, Manav, please go on.
Hi everyone, can you hear me?
Yeah, Manav, we can hear you.
Yeah, I am Manav, I am founder and CEO of Single Programs. Today I want to talk about the most interesting topic we call why coding agents fail in real production code base. And it's an interesting topic basically. So we have seen impressive demos and AI agent builds a to-do app, creates a landing page or generates 100 lines of code in a minute. But when the same agent enters a real production environment with millions of line of code, multiple teams and business constraints and security requirements and complex workflows, things start to break. The reality is simple. Coding is only a small part of software engineering. So we are going to dive into the today's talk how we can increase our workflows more accurately and more systematic way to build a productionized apps. So why coding agents fail? Let's look at the major model failures. First, lack of context. Production systems are huge. Agents only see small portion of the code base at a time. They might change one API unintentionally break five downstream services. And the second reason is hallucinated APIs. Sometimes agents confidently use functions, SDKs, or libraries that doesn't actually exist in the project. And third, poor architectural understanding. They may write correct code but completely ignore the design patterns and conventions the team follows. And the fourth reason is multi-file reasoning. Real fixes usually touch backend code, front-end code, database infrastructure, and test and documentation. Agents often modify only when keys and leave the system inconsistent. And more importantly, there is no security risks like SQL injection and performance benchmarks too. And the reality is business and engineering reality. Now let's move beyond code. One of the biggest issues of the lack of business context is the AI doesn't know why a feature exists. It doesn't understand customer contracts, compliance requirements, or regulatory concerns unless we exploit provided information. Then there is testing. Many people assume passing test means success. It doesn't mean that. Test may not cover every scenario. Integration failures, performance regressions, and edge cases can still move into production. And second is security and performance. Another major concern is security. Agents can accidentally introduce injection vulnerabilities like leak of cigarettes, misconfigure of auth, or recommend unsafe dependencies. Another code might work perfectly on a laptop, but create N plus one database requires increased latency, consume excessive memory, and fall well under production traffic. And for that, long thousand tasks and human judgment is very important in this era of AI agents. Large refactors, multi-week projects, changes spanning several pull requests require planning and memory over time. Most agents lose the track as the complexity increases. And because most importantly, software engineering is a collaborative activity. So what is the missing layer in it? The missing layer is that this brings us to what I believe is the most insights. The problem isn't the AI can't generate code. The problem is that software engineering is a workflow. Requirements lead to design, design leads to implementation, and implementation leads to the testing, and testing leads to the review. Review leads to deployment, and deployment leads to the monitoring. Most agents only optimize one stage implementation, but rest of stage is ignored by the agents. So what about global rules, right? And global rules, or repo and task context. For agents to succeed in production, they need multiple layers of understanding. First, global organization rules, security policies, coding standards, compliance requirements, and naming conventions. It's a very important to give a context to the agents and updating day by day to day or task to task without updating your agents fails to ship that feature basically. And second rule is folder structure, testing strategy, framework, and CI/CD pipelines. And the third Pacific is context, the bug, the feature or user requirement worked on. Without all three agents make decisions that look correct locally but were wrong globally. And the context in MD, the missing knowledge layer. Context MD, the architecture MD, the rules MD, and agent MD. There are four files which use agents of memory layer or context layer to act as a persona. These documents give agents knowledge about system architecture, business knowledge, business logic, deployment process, and organization rules before they start coding. They're also saying the evolution of agent loops. Instead of prompts, response the workflow becomes observe, plan, code, test, analyze, and improve. The agent continuously evaluates its own work. But why agent loops still fail? But even agent loops aren't enough. Agents can get stuck fixing the same issue repeatedly. They can optimize the wrong objective. They can forget earlier decisions. They often lack persistent memory across sessions, and coordinating multiple agents remains extremely difficult. That's why human oversight remains critical. And the closing part. So we comes to the end of the session. It's not a deep tech session, but it's just how you can improve your session, how you can improve your workflows with working with the agents. At the end, I'm showing a demo how you can create a graph of neural graph with your code base. Can your agents can get a context from that, and you can see the connected nodes to the agents. The future isn't smarter than other companies. The future is an AI engineer that understands architecture, framework, context, follows org roles, collaborates with other agents, uses automated verification, and works alongside humans. The take away. I want everyone to remember this. This coding is only about 20% part of software engineering. The 80% of the part is context, architecture, workflows, business requirements, and security. More importantly, security and the performance. And most importantly, human in the loop. When we solve those layers, we'll move from AI code generation to true autonomous software engineering. So I'm going to show you the live project which I'm working on an AI agent, which is called ARIA. It's a medical agent which is going to deploy in some bits. So how we can create a memory address systems using Graphite. So over you can see this is a layer which I created using Graphite. It has it has all my files which are interconnected with so much sessions like tool entry, the org window. All our files are connected in the loop. That it's not a loop; it's a neural network basically. Or your agents can remember everything about your project, what you did and what you not did, and where the nodes are connected with each other. So it acts as your database for it. And this is my project. So all these files are connected to a graphite memory, which stores my every session line by line. Every session is stored in a types of nodes which are interconnected with my files. So my agents doesn't lose my context. There are different types of software you can do with it, like graphite, like Neo4j, integrated with Cloud Code. Yeah, so we can end this session over here.